Hello, environmental scientists. This is Mr. S, and today we're talking about lesson 3.4, carrying capacity, which is the carrying capacity is the maximum occupancy in an ecosystem, just like the maximum attendance that people could be at a concert or in a restaurant. And there are limiting factors in the environment that limit how many organisms can live in an environment. And there are different carrying capacities for different organisms. So we want to practice the learning objective of describing carrying capacity. And the essential knowledge for you to take away is that when a population exceeds its carrying capacity can be denoted as K, overshoot occurs. There are environmental impacts of population overshoot, including resource depletion. And a major ecological effect of population overshoot is dieback of the population, often severe to catastrophic, because the lack of available resources leads to famine, disease, and/or conflict. Okay, so, and the other one is to describe the impact of carrying capacity on ecosystems. So you'll need to be able to take these concepts and be able to explain them in depth. And the suggested skill is to explain what the data implies or illustrates about environmental issues. All right, so carrying capacity is the maximum number of individuals in a population that an ecosystem can support based on limited resources. So if you look at figure 1, it's theoretical. This is what we always look at as a classic carrying capacity, where there's exponential growth and then something happens and the population growth falls to 0. But in real life, this is what it looks like. So it goes way past how many animals can live in the ecosystem, and then there's a big die-off, and then it eventually undulates and goes back and forth due to seasons and what predators are there and what's happening, and gets kind of it'll kind of get closer to that line, as you can see. And carrying capacity is, again, the highest population size an ecosystem can support based on food, water, habitat, all of those things that are available that can change. The overshoot is when a population briefly exceeds the carrying capacity. Like when deer breed in the fall, they give birth all at once in spring, and there's a huge sudden spike, and then too many of them, and then a lot of them die. A consequence of the overshoot would be resource depletion. So for example, overgrazing with these deer. And then a die-off occurs where there's a sharp decrease in population size when resource depletion or overshoot leads to many individuals dying. So for example, many deer starve when there's too many fawns feeding in the spring. And an example of this is the reindeer in St. Paul Island. 25 were introduced in 1910, and the growth was gradual at first, and then it became exponential. They depend on lichen in the winter, and they ate too many of the lichen. The lichen wasn't able to grow back in time, and this led to a sharp die-off and population cry as the lichen were depleted. So if the resources are depleted severe enough, then the total population crash can happen. So in this case, they were introduced to this new island and they spiked up, and then their resources were depleted too much, and they went all the way down to 8 species. And then they adapted to digging up grasses in the winter, luckily, and so now there are 400 today. They were lucky to bounce back. So their carrying capacity is now around 400. And here's an example of predator-prey interactions with carrying capacities. So hare populations, or like rabbits, increase due to the low predator populations of the lynx, and the lynx populations increase due to increase in food. So they go up and down together. Okay, and then increasing lynx population limits the hare population and leads to die-off. and the hair die-off decreases the lynx food source, leading to the die-off of the lynx. The hare population increases due to low predator population for the lynx. So you can see they grow together, and then when the hare population went down a lot, the lynx population, they were starving. Then there were less lynx, so the hares went up again, and the lynx went up again. Then when they went down, they just match each other. So in the end here, the hare's carrying capacity would be about 60, because that's kind of where you would draw the line. And it would be about 40 for the lynx. Okay, because that's like where the line would go through, where the waves average. Okay, and on the next slide, you're going to practice free response question 3.4, which is explain the impact that the canine virus had on the moose population based on this graph. So you can see where the wolves were struck by the canine virus, and how did this affect this purple line, which was the moose. All right, good luck. We'll see you next class.